Right, guys, welcome back. We are back in here. Go over the nest. Yes, ready, good. Um, so 3 people, Nagesh, yes, 4. I got 4 volunteers for tomorrow's introduction. So there's one more. With that, we can be done. All right, so let's take a quick look at your textbook. What your textbook talks about. So we talked about data independence, file organizations. We talked about all these. All right, so it's time for a story here. Okay, so let's talk about. Okay, I'm done. Okay, now I'm going to take next 15 minutes for a quick story. I'm going to go a little over your time 6:30. If you guys want me to stop, let me know. I can go over until 8:15 for me, which is like I think 6:45. So if you want me to stop, let me know. All right, different types of architecture. Again, this is another important question. I think you have like 5 more questions. That is something I'll do later in the day. Not later in the day, later down the line. I wanted to run through how the marks are distributed in your exams. What kind of weightage each question carries. I think there's roughly about 17 or 18 marks of weightage in your exam. I want each of you to get all those 18 marks full. That's my interest. After all your exams are done, maybe a few months later or a year later, I don't know when, I would be happy if I get some feedback from you guys. How did the exams go? Okay, so I will run through your question paper a little bit later, and then the distribution of the marks, what carries what weightage, things like that. We'll do that before we are done. Okay, I'm sure you might have done, but I will do that from my side a little bit. Now, this is again an important question about different types of architecture. There is a client-server technology. I don't know if you guys have studied client servers so far, or is it something that you will study later? That's a very important term. You'll keep listening. Client server. What is a client server? To put it very simply, client server basically, in very simple terms, and it is truth. Okay, not in computer terms, but in simple terms, a client is basically who's asking for a service. A server is one who's providing the service. Okay, server, the term is mostly used in restaurants. If you want to use the term server, is used in restaurants, right? What does a server do? Server goes, gets something and serves it, all right? That's, if you remember that term very simply, a server is one who goes in, gets what you want. So you go to a restaurant, you tell your server what you need, he goes, gets what you want, serves you, right? So you become the client there and he becomes a server there, okay? This term keeps changing, or the role keeps changing. We all play different roles in our life at different times. Like, when I am here talking to you, maybe you can call me an instructor, teacher maybe. But when I'm done with the session, when I go into my family and I take different role, I assume the role of maybe a father for my kids. So everybody takes different roles. So client server keeps changing. You could be a client now, but you could be a server at some point of time. So the role keeps changing based on what you're doing. So simple terms, a client is one who is asking for a request or who's placing a request. A server is one who satisfies the request. Simple, okay? Now, we're going to talk about different tiers of architecture, okay? We talked about a little bit before, but I want to go really a little bit deeper, talking about different layers of architecture. There are 3 levels we're going to talk. Logically, there are 3 levels of architecture: one tier, 2 tier, and 3 tier architecture. What is a 1 tier architecture? 1 tier means 1 layer. The term tier and layer are usually used, hand in hand. 1 tier means there is only 1 layer. There's no other layers. Okay. What is that layer? It is a database layer. Okay. So let me tell you this story. This is what I want to say before I go into that example. Let's assume you go to a restaurant to order some food. Okay. So the restaurant, let's say, opens at 6 in the morning, okay? The people are allowed to come in at 6 in the morning, but the cook or the server do not come into the office at 6. They come early, right? The cook starts cooking earlier than 6 o'clock. So the food is ready for his customers, the client, at 6 o'clock. So the cook comes in, prepares everything. Let's take example of he's making an idli. What's a famous dish in Mysore? Bath. I know wangi bath, bisibele bath. I don't know if I'm saying it right. Any interesting dishes in Mysore? Anybody likes a specific dish? All right, until I get a response, I'm going to use idli. So the kesri bath. Okay, so I don't know how to make that. So thanks. So what the cook does is he prepares the food in the kitchen, right? And before he serves, he does a tasting of the food, right? He has to make sure the food is all in form, all is good. So he tests the food. He tastes the food and tests the food. He does both, right? He just want to make sure it is tested properly. So he tastes the food and tests the food for it to come out to its customers. So the food exists in the kitchen. The food is prepared in the kitchen. The cook who's cooking the food stays in the kitchen. Now, who is consuming that food in the first place is your cook. So the cook also stays in the kitchen. So everybody stays in the kitchen. There's only one layer. The restaurant is not open yet. So everybody stays in the kitchen. Make sense? So now here, the client and the server all stay in the same place, same layer. So this is what I mean by one layer or one tier architecture. Okay, make sense? Now, what it means is in terms of, or maybe, let's go a little bit. So the client in this place is the cook itself because he is consuming the food. And the server here is again the cook because he serves the food to himself, right? And the layer we're talking about kitchen, okay? So this is one tier architecture. Both the database and the user of the database stay in the same layer. So here the database, for example, is the kitchen, or the data is the food, okay? So the food is the data and the consumer is the cook. Both stay in the kitchen in one layer, okay? So the client and the server here pretty much stay in the same layer. Make sense? This is called one tier architecture. A lot of times people take away the story, but not the concept. Please, the intent of me introducing a lot of stories. For example, if you remember, I told you a story, I think the first or second session about applications of database, okay? The intent of me telling you a story is not to take away the story, it's to take away the concept, okay? So a lot of times people take the story but forget the concept. That's not my intent. So please remember the story, take the concept along with it. So your concept should travel with the story, okay? So you don't forget it. So even if you go to the exam, you're blank, I want you to close your eyes and think the story that I said, for everything, associate a story more like your mind mapping, bring it to your mind with a story built. So if you build a story, you'll be able to bring it up, okay? In telecommunication, in engineering, I studied this. If you want to throw a paper far, how far you can throw a paper. For example, if I just take a piece of paper that I can use, just throw it off. For example, I have this paper. If you want to throw this paper, it doesn't fly far, too far. If I really want it to fly farther, what I do is I put some kind of a weight to it, attach a stone or something, crumble it. I can just crumble and throw. It still goes a little further, but I can put a stone, heavy stone or heavy object, and then crumble it and throw it too far, right? That way it travels very far, but actually what is carrying this paper is basically the stone. So the stone is basically my story, okay? I want my story to enable the concept to go with you, okay? Because the paper cannot travel on its own further, I'm just attaching a story. So bottom line, don't just get the story and forget the concept. Make sure you carry the concept, okay? Now, moving on. So how do you relate this one-tier architecture to a DBMS? So in simple terms, your DBMS and the users of the DBMS stay in the same layer. What do you mean by the same layer? So you create a DBMS and your user is basically, in this case, will be an application programmer. An application programmer who writes application programs. So he will look at the DBMS using queries. He will use SQL, structured query language, to query the database. So he's going to write an application program for somebody. For example, banking system again, an ATM. If you're creating an ATM, you want to know if I press this button, this query should be triggered. So before that functionality is built, the application programmer wants to test it. So he will write a query internally and talk to the database. He will write a query, select balance from table name, whatever table it is, to see that it's fetching the correct balance. Excuse me. So there is no user interface. He's writing a raw SQL. You understand what I'm speaking? So he writes a raw SQL to talk to the database. There's no front end, no user interface, nothing. You're talking directly to your raw database. Okay? So that is what I'm trying to mean. The users of the database, in this case, is an application programmer, the database designers, they all talk directly to the database using an SQL, and they all stay in one layer. Okay, here the client and the servers stay in the same layer. Okay, internal layer, and that's called one-tier architecture. Okay, let's move on. Two-tier architecture. Let's move on to the two-tier architecture. So let's go back to our same example of the restaurant. So now you go to the restaurant is open, 6 o'clock, you walk into the restaurant, okay? So a lot of small restaurants do not offer a menu card, you know. You guys know what they sell, you know. I've been to a few restaurants in Bangalore and Mysore. They are famous only for a specific item, you know. You go to the restaurants, you don't ask for something else. You only go there to eat specific food there, right? So such restaurants don't typically serve a menu card. They don't have a menu card. You just walk in there and say, okay, idli, dosa, whatever it is, all right? So, but there will be a server who will come and receive you, seat you in a table, and you talk to your server and say, okay, can I get a plate of idli? So you're talking to a server, he takes your request, goes back into the kitchen, he gets the food, comes back, serves you on your table, yes? So here if you see, we introduced two layers. One layer is basically you, the client, who is wanting something, who's placing a request for some food, for an idli. The server takes it to the DBMS and then comes back serving you, right? So there are two layers here. You are sitting in the front of the restaurant, okay, the service place of the restaurant where the client sits. We have a server at the back end who is serving you from the restaurant. Make sense? We're talking about two different things here. So you become the client, he becomes a server. There are two layers. You where you are sitting, there's a kitchen layer where the food is stored or where the data is stored. Okay? So now in this case, there are two layers. Okay? So you're talking to the DBMS through an application program. What is an application program? You write C, C++, Java, etc. To fetch I'm getting a little warmer here. So. Okay, so you're fetching your data through an application program. So in previous case, you're fetching the data through SQL. Here you're not using an SQL. Instead, you're running a COBOL program, let's say, or you're running a Java program or a C++, you're compiling a program, not knowing what query is used. So when you compile the program or run the program internally runs a query behind it. The query hits the database, fetches the data for you back. So here, compared to one-tier architecture, in two-tier architecture, you have an application program. So I think there was a question earlier, I don't know if it was Ashish or somebody was asking, what are the different programs that use DBMS? So I think I answered your question now. So every application program has a DBC called a database connectivity. Generally, it's called Oracle Database Connectivity or Open Database Connectivity. Oracle calls it Oracle Database Connectivity. So ODBC means Open Database Connectivity. What is that feature doing? This feature comes with DBMS. What does this feature do? This feature connects your application program and the DBMS. Okay, the application program will have certain logic plus your query. Whereas in one-tier architecture, there is no application program. For example, I cannot take an input data. For example, I want to say what is the bank balance of, let's say, here's my name, username, Govardhan. Okay, so I have to go write a query in one-tier architecture. I have to go write a query myself saying select bank balance from this table where name equal to, within bracket, I have to give Govardhan. So for Govardhan, I get the data. So I'm physically giving the data in the query. Whereas in two-tier architecture, I can supply the input through an application program. So I can write an application program, C or C++, Java, whatever, to say, receive the input from the user. So it receives the input, it will ask me, for who do you need the bank balance? So I can give a name Govardhan. So it takes the name Govardhan, goes to the application program, puts the name, runs the query, get it. In next 5 minutes, I may say, okay, can you get me the bank balance for, let's say, Manjushri? So now it takes the name, goes to the application program, fits the name, Manjushri, gets it. Next, for example, Krishna, fits the name, puts it. So every time I have an advantage to run the query by dynamically changing the name. The name is not static. It's dynamically changed during runtime. Okay? And the SQL is embedded in the application program. I'm using new terminologies. I mean, these are used in the DBMS, but you don't need to worry too much. So I use the term static versus dynamic. Static means it's very static. You cannot change the input. Dynamic means at runtime, you can change the input. Like I'm changing the name. Govardhan, Manjushri, Priya, whoever it is. And embedded SQL means I'm embedding my SQL into your application program. Make sense? There is an application logic written to say, get the name, do something, then run the SQL, get the data. Make sense? This is two-tier architecture. So in two-tier architecture, compared to one-tier, there is an application program involved. There is a database connectivity involved. And these two sit in two different layers. The data, the DBMS sits in a different layer, which is the server. The client, the application program sits in a different layer. Make sense? I think I want to stop here. I feel it's kind of heavy, too much to assimilate, but I think we can stop here for today. I'm open to take questions for the next 5 minutes. If you guys have anything specific, feel free to ask questions. Okay, and thanks again, everybody. I'll see you again day after tomorrow. Come back with your introductions. Thank you. See you soon.